Hello. In this program, we will be looking at right triangle trigonometry. We will be dealing with right triangles, and we will be looking at SOHCAHTOA as well as Pythagorean theorem. Those are going to be the two main concepts that we will be using in this program. So before I jump into some programming and coding, let's go over what I've done here. So what I've done is I've created functions to get user inputs for theta, opposite side, adjacent side, and hypotenuse. So these functions are only taking user input, and they restrict those values to positive inputs only, because the length of sides and angles are assumed or ideally are positive in this program. All right, and then we have our print menu function. This is the main the main concepts we're going to be looking at. So this print menu will be given to the user, and they will make a choice, and based on that choice, we will be doing the computation. So we'll be doing the print menu is going to be looking at, if we're given theta and an opposite side, we will solve the whole triangle, and then there are three other choices they can make, and we will be solving the triangle based on them. Okay, and then if they choose option 4, given two sides, find the rest. So we'll ask them what two sides do they know. Do they know opposite hypotenuse or adjacent hypotenuse, and so on. So that's another print menu there. And then here are the functions that we need to change. So given theta, opposite takes parameters theta opposite, and we will need to change this print command. It says Berlin. These are cities in Germany. So I put it in there for fun. We will need to change these cities, and we will need to make the right functions that will do the right computations for us. But when I do run the program, our main function, well, we don't have a main function, but when we run the program, the flow of it is correct, and exception handling is also correct here. So let's run the program and check exception handling here. Let's delete that. So run the program. So we're going to choose option 5. That's not one of them. It says invalid, try again. Enter a string, it doesn't do it. Let's enter number 1 or 2. And for theta, we'll enter a string. It says it needs to be a number. So if we enter -7, it shouldn't take it. It says it must be positive. So it has to be positive. We enter positive values. Here we have to enter positive. And then when we do, in this case, it says Hamburg, and then the program asks us if you want to exit or not. So we know the exception handling is working for us. So all we have to do is now go to our program and make the changes for the functions here, starting with theta opposite. So I will go ahead and make those functions. So for this one, this first function here, we need to come up with some variables. So the first one will be adjacent. This equals opposite over tangent radians theta. So this is basically math here. So when we have tan of theta is opposite over adjacent, if we solve for adjacent, we get opposite over tangent. And the command here, radians, is the right option to do the computations correctly. The radians here converts it to degrees here. I'm not sure how to explain that, but this theta, when we have it in radians of theta, it is actually theta in degrees. So in next line of code, we're gonna define hypotenuse. So this equals obviously square root of opposite square. All right, so that is hypotenuse is from Pythagorean theorem. So it's the square root of the opposite squared plus adjacent squared. And then for theta 2, to calculate it, this is the theta that is not opposite of this is the second theta. We have three angles in the triangle. The third one is the right triangle. The first one was given. The first one is a theta that the user input. So theta 2 is part of let's do it like that. Theta 2 or like this. This equals degrees. 8, 10. Adjacent, and this is over opposite, like that. So it'll theta 2 will be the degree version of arctan of adjacent over opposite. So if we're looking at, if we have theta 1 is opposite over adjacent, then if we have the triangle, assume we have a picture, and theta 2 in that case would be adjacent over opposite, and we take the arctan of that. Okay, and then now we're going to print a blank line, and then next we're going to print the results. Print All right, so that's how we create our first function. In this case, our function will take parameters theta and opposite that the user will input, and then we will calculate for adjacent, hypotenuse, and theta 2. Theta 3 would be the right angle. That's not included here. And these are the commands are here. These are all mathematical computations. Opposite over tan, tangent of theta, and then hypotenuse is a squared plus b squared, right? So that would be the square root of opposite over adjacent, and then theta 2 is arctan of adjacent over opposite, and that's in degrees. And then we print the results to the user. That's what we're doing in these functions. So when the user inputs, say, this function here, they want to know, they want to solve the whole triangle based on theta and opposite. They want to input that. We will do the computations, and we will print here the results that we computed, those three things, to the user. So now I'm going to make the rest of my functions, and we will come back. And all right, so we're back. So after the first function, I made, let's see, 4 more functions. 1, 2, 3, 4, 5 more functions, and they follow the same procedure, obviously different math aspects, but they compute based on the parameters in each function. They compute the unknowns, and then we print those unknowns to the user to solve the triangle. So the first one is theta adjacent. That'll take theta and adjacent as input from the user, and then we compute opposite, hypotenuse, and theta 2, and then we print those results to the user. The third function, the parameters are theta and hypotenuse that will be inputted by the user. It'll compute opposite, adjacent, and theta 2, and then we print those to the user. And then the second to last function is opposite and hypotenuse. So this is a function that the user inputs those two parameters, opposite and hypotenuse, and then the program will calculate adjacent theta and theta 2 and print those results to them. And then last one is if they know adjacent and hypotenuse and they input those values, we compute opposite theta and theta 2, and then we print to the user. Actually, this is the last function here, opposite and adjacent, and this is the one that uses arctan or tangent. In this case, it's arctan, and we print the results to the user. So let's go ahead and run our program and see. Let's actually open our book and choose an example from the textbook. We're going to solve, let's make this bigger. We're going to solve example 4, solve a right triangle based on theta and an adjacent side given as 10. So let's run our code. So in this case, it's given theta and adjacent side, so number 2. Oops. We want to enter number 2 here. And let's see what theta was. I think it was 35 and 10. So theta is 35, adjacent side is 10. And we get opposite side is 7, hypotenuse is 12.2, and theta second is 55 degrees. See if that's what they have. So theta 2 is 55 degrees, x is 7, and z here, they call that is the hypotenuse, is 12.2. All right, let's do another example. Let's see here. Let's do one from the previous page. Let's do one when we know the theta and hypotenuse here. So let's run our code again. So I'm going to say no. So what are we given? We're given number 3, theta and hypotenuse. Theta was 30 and hypotenuse is 8. So theta 30 and then 8. So theta 2 is obviously 60, and then we get 3.9999. That is 4, and adjacent side is 6.92. Let's see what we're solving for. We're solving for adjacent. If they get their answer, it's 6.9. It's given down here as a decimal. Our program doesn't compute, doesn't print out nicely, such as 4√3 or anything. It'll give us the decimal approximation instead. All right, let's do another example from page 762. So let's see. So we're going to solve this triangle in our self-check here. I believe we did this in the video that we did about right triangles mathematically, but let's see if we get those values if you want to check that. So our theta is 70 and the opposite side is 18. So we're going to run our program. We're going to say no, and then so it's theta and opposite. So hit number 1. So theta was 70 and then opposite is 18. 70, 18. So theta 2 is 20, hypotenuse is 19.16, and adjacent is 6.55. Those are the values. They don't have the answers, obviously, here because it's a self-check for us to do. But an exercise for you would be to compute these by hand or your calculator or whatever and check to see if we get the same things that the program is getting. So let's run it again a couple more times and we'll be done. So let's do a 5, 12, 13 triangle. And that's a famous Pythagorean triple triangle. So we're going to choose option 4. So what do we know? We're going to say opposite and adjacent. So I. I'm going to choose that option. So opposite is 5 and adjacent is 12. So the hypotenuse is 13. Our first angle is 22.62 almost, and then the second angle is 67.38. And we can change these numbers to do a percent point 2f and have a 2 decimal approximation value instead, if you want to. So let's do a last example. Go to page 760 of our text, and we're going to do this problem here. So we know the adjacent, assume this is angle is A, that is theta. So 2 is the adjacent, and then the hypotenuse is 5. So let's do that problem. So which option is that one? It is number 4. It is adjacent and hypotenuse, I. So the adjacent is 2, and then hypotenuse is 5. And we get that the opposite side is 4.58. And is that what we're solving for? Let me see. A. Yes. Let's see if. So it's root 21, basically. All right. So the book computes the side A here and gets that A is root 21. And the problem solves for tangent of A. That's what it's asking. Find the value of tangent of A. And the tangent of A is root 21 over 2. But the opposite side is root 21. And our program says the opposite side is 4.58. So let's see, 4.58 is root 21. So we hit 21 and take the square root. It is 4.58. So we get this right answer, but the textbook is asking for the tangent. So it's something that I wasn't fully paying attention to. But the program is running it correctly and efficiently for right triangle trigonometry. All right, so this was a program, Python program for right triangle trig. Thanks for watching.